Good morning, everybody. This is objective 2 of topic 2 of solving quadratic functions by factoring. And this is the first strategy that we're going to learn about factoring. All right, so objective 2 states, solve quadratic equations by finding the greatest common factor. And I'm going to shorten that by saying GCF. All right, so you hear me say GCF a lot throughout this module. This technique is important to consider as well, that you can use this technique when the a and b terms are present of a quadratic function, okay? Only the a and b. Another way to say that is, if you come across a quadratic function and it has no c term, so please write that down as well for a reminder. If it has no c term, then you can also use the strategy of factoring by finding the greatest common factor, all right? So no c term is another clue for that, or just when the a and b terms are present. All right, so if I was given this first example, I'm going to do this example, the ID problem, and I'm going to have you, within the video, please pause the video, try that problem on your own, number 8 down there, unpause the video, and check your work within the video so you can just check your understanding before you step into the practice. But I'm going to do this example exactly like how I would want you to do all of these factoring by GCF problems, all right? So the first step says to get it into standard form with the right side equal to 0. If you notice now, these are equations. This whole module is called quadratic equations. Equation is signaled by the equal sign. 3n squared equals 24n. All right, so my goal in step 1 is to get it to equal 0 on the right-hand side. I have listed standard form up here. It's the ax squared plus bx plus c equals 0. And so if you notice, and this is important to do as well, please identify your a and b term. This is a, this is b. All right, my a term is 3n squared. A term is always the quadratic term, variable raised to the power of 2. The b term is 24n. The b term is always the linear term, 24 or n to the power of 1 in this case. All right, so I need to move. If you notice, the b term sits between the a and c, but there's no c, so the b term comes after the a term. I need to move the b term over to the left-hand side because the right-hand side needs to equal 0. I'm going to do that. This is a positive 24n. I'm going to do it by subtracting 24n. I'm just subtracting the term from itself to get it to equal 0. Whatever I do to one side, I have to do to the other, so I'm just going to write it below the 3n squared. And now, if you notice, 24n minus 24n, the right-hand side will indeed equal 0. And if you consider 3n squared minus 24n, those are not like terms, so I cannot combine them. If you remember, like terms exist if the powers are the same. N squared and n to the first are not the same, so these are not like terms. So at this point, I just write it in standard form with the quadratic term coming first, 3n squared minus 24n. All right? There will be times when you're moving terms around and there will be a like term on the left-hand side that you will have to combine terms with, but this is not one of those times. All right, so at this point, I have found standard form right here. This is standard form. I'm going to write that above, so please make note of that, standard form. It's important to know that this is standard form because we're about to get this into factored form, and you need to be able to tell the difference come test time, all right? Factored form is super important, and this whole process is about factoring quadratic functions because from factored form you can solve each factor and find the solutions or the roots or the zeros or the x-intercepts if they cross the x-axis. Now let's do step 2. Determine the greatest common factor between each term. Alright, if I go back to my standard form, this is the process of getting it into factored form. I have one term, the a term, and the b term, right? I need to find the GCF, the greatest common factor between, so I'm going to do step 2 right up here. The GCF between 3n squared and negative 24n, but I don't have to bring the 24n until later, or the negative in until later. So the GCF between 3n squared and 24n. Alright, in order to do that for the coefficients, or the numbers, 3 and 24, I need to get them into prime factorization. So I'm just going to do factor trees, a skill from Algebra 1. 3 is already a prime number, but I can factor it into its only factors of 1 and 3. 24, there's a couple different ways you can go about this. You can choose 6 and 4. 6 times 4 is 24. 12 times 2. I'm going to do 8 and 3. 8 times 3 is also 24. I did that because now if you see I have 3's in common, that'll help me. I can break down 8 into 4 and 2 and the 4 into 2 times 2 as well. And now I've gotten prime factorization from 24. At this point, when it's all the factoring is done, you can't get any more factors for any of the numbers, you look for the greatest in common factor, or the greatest in common number between the original 3 and 24. And in that case, it is 3. 3 has a 3 of a factor, and 24 has a 3 of a factor. So the GCF of my numbers is 3, all right? I'm going to put that right here. Just make note of that, okay? Because we still need to do the variables. Now, I'm going to draw a little separation. 3n squared, and then the 24n. All right, so I have to find the greatest common factor between the variables as well. If you remember, n squared just means n times n, so technically the factors of n squared are n times n. Or another way to think about that, whatever the power is, so it's n squared, that's how many n's exist within that term. So there's 2 of them for this case because it's a power of 2. If it was the power of 3, then there'd be 3 of them. And in this case, this is the power of 1, so it's really 1 times n, or there's just 1 n that exists in that term. So from here, I look for in common factors, and if you notice that these 2 terms of the variables, n squared and n, only have 1 n in common. So that becomes the second piece of the GCF, all right? I found the GCF of the numbers, which was 3, and then I found the GCF of the greatest common factor between the variables, which was n. So I am done with step 2. I have determined the greatest common factor between each term. I'm going to move on to step 3 now. I'm going to factor out the greatest common factor and then rewrite everything in factored form. All right, so I'm going to do step 3 right here. The first part about factoring out the greatest common factor is I need to write the greatest common factor first, all right, before the binomial. Then I write an empty binomial for now, okay? Because I'm going to write within that binomial, or within those parentheses, I'm going to put my answers to what happens when I factor out the greatest common factor from each term. At this point, factor is another word for division. So I'm going to divide the greatest common factor from the first term and the second term back from standard form. So at this point, I'm going to go from standard form and get it into factored form. Now, this process does take a little side math, unless you can do this in your head. But if that's something that's a challenge for you, then please, I need to see the side math before you ask me any questions about how to do this process, okay? I am going to take my first term of standard form, which is, so I'm going to do side math right here. It's 3n squared, and divide my GCF from it, 3n, all right? I'm going to write what that equals right here. 3 divided by 3 is 1. I don't have to put 1, though, but I can just know that it's 1. And then n squared divided by n, you can think about it 2 ways. Base divided by base, you subtract the powers, and that's technically a 1. So 2 minus 1 would be n to the 1. Another way to think about it is n squared means there's 2 n's on top, and n to the 1 means there's just 1 n on the bottom, so I can cross out like terms as well. And I'm just left with 1 n on top. So after I divide out 3n squared by the GCF of 3n, I'm left with n. And my first answer of that term goes first in the binomial, all right? Now let's move on to the second term, which is negative 24n. I'm going to divide it by the GCF of 3n, and this math looks a little different. And again, it's important to know if it is minus the second term, minus 24n in this case, you do have to bring that negative sign along for the ride when you do this math. If it's plus, you can just consider it positive. All right, so negative 24 divided by 3 is negative 8. And then there's 1 n on top, 1 n on bottom. They cancel out. So my second term that's left after I factor out the GCF from it is a negative 8. And that answer goes second in my binomial. So at this point, in step 3, I have rewritten the standard form equation, 3n squared minus 24n, into factored form. So you need to make note that this is factored form, all right? This, please square this because this is super important. That is factored form, so that you can reference that within your notes as you practice this homework on your own. All right, so from factored form, again, factored form is so important because now I can start solving each factor to find the solutions. Step 4 says to use the zero product property. All that means is I'm going to set each, so I'm going to continue down the page. I'm going to kind of box off this side work. I'm going to do step 4 down here. So each factor, 3n, and then in this case, n minus 8, those are both factors, all right? 3n is by itself, and n minus 8 is trapped in those parentheses. I'm going to set each of those factors, because technically, I'm sorry, this is equal to 0, so make that go around like that. Everything is equal to 0 because they're equation. Each one of these factors I'm going to set equal to 0, all right? I'm going to separate them. And then n minus 8 is trapped in the parentheses. I can free it up when I set it equal to 0, though, so n minus 8 equals 0. At this point, then, this is step 4. That's the zero product property. You just set each factor equal to 0. That's what that property means. And then step 5 says to solve each factor to find the solutions to the equation. So in this case, it's just doing a little math. Sometimes you'll get fractions when you do this process. Sometimes you'll get whole numbers. It just depends on what the factors are. So the first one, I'm going to divide by 3. Divide by 3. 0 divided by anything is 0. So I have found the first solution, n equals 0. Over here, it's n minus 8, so I have to add 8 to both sides. So the second solution is n equals 8. And I am done. I have found the two solutions to this original standard form quadratic formula. All right, so if I were to graph 3n squared minus 24n in your calculator, it would cross the x-axis at 0 and 8. All right, so you learned how to graph or solve quadratic functions and find the x-intercepts or the solutions or the zeros. Graphing, now you're learning how to solve them by factoring as well. And it's important to know both because at times you'll use the calculator, at times you won't be able to. I have found two solutions though, and if you see a relationship between the original standard function, the power of 2 means that you'll always be looking for two solutions. All right, the highest power determines the number of roots, and we're going to talk about that in later modules as well. So at this point, please pause the video and try number 8 on your own, and then check your work with mine when you're done. You should pause the video and try number 8 on your own. The first step is to get it into standard form, m squared plus 4m equals 0. I did that by adding 4m to both sides because it equaled a negative 4m. The second step is to find the greatest common factor. This was a little bit confusing, I suppose, because m squared and 4m, the greatest common factor between, if you remember, the number before m squared is 1, so the greatest common factor between 1 and 4 is just 1 for the numbers. And then you have to find the greatest common factor between the variables, m squared and m. There's only one m in common right here. So that's how I found my GCF. I wrote it in factored form. Step 3 is very important in factored form. I didn't put the 1m because you don't have to, so it's just m times, and then m squared divided by m gives me 1m. 4m divided by m, the m's cancel out, and it gives me 4. All right, and in that process, if you didn't understand that, you got to do some side math. First term divided by greatest common factor, second term divided by greatest common factor. Set each factor equal to 0, and I solve, and this is the answer. M equals 0 and negative 4. At this point, if you didn't get that for your answer, if your work doesn't look like mine, please raise your hand and I'll come over and check it.